Welcome back to Easy Concept. Today, this is the class on prestressed concrete structure. Prestressed concrete structures. So, prestressed concrete structure that we are going to see now. Okay. So, first we are going to see what are the advantages. Advantages of this is PSC, pre-stressed concrete structure. Advantages of pre-stressed concrete structure. Okay. The first point is a smaller section. Yeah. Smaller section size as compared to a smaller section size as compared to RCC. As compared to RCC, the section size is smaller. That's the first point. And the second point is concrete is more utilized. Concrete is more utilized. Okay. Third point is cracks are less as compared to RCC. Okay. Now, lesser dead load of superstructure. Lesser dead load of superstructure. So if the size is small, then automatically the dead load also small, right? So these are the advantages. See, a small section size as compared to RCC. Concrete is more utilized, but in the RCC, concrete is not that much utilized. Then cracks are less compared to RCC. Then lesser dead load of superstructure. The superstructure dead load is very less. Okay, and the second disadvantages of this is disadvantages of prestressed concrete structure. What is a disadvantage? The first one is costly as compared to RCC. Costly as compared to RCC. Not suitable for small work. Not suitable for small work. So this costly is very high and not suitable for small work. Next one is more technicality involved. More technicality is involved. So skilled manpower is required. So skilled manpower is required. Now, loss of stress of wire leads to poor performance. So in the prestressed concrete structure, there was a loss. Due to that loss, the wire or a cable perform as poor. Okay, so these are the important point about the pre-stressing. Now, second one is the types of pre-stressing. Types of pre-stressing. So the types of pre-stressing, the first one is pre-tensioning. Next one is a post-tensioning. First one is pre-tensioning member. Okay. Next one is post-tensioning member. Next one is post-tensioning member. This is the pre-tensioning, this is the post-tensioning. In the pre-tensioning, which is done by Fourier method, The pre-tensioning is done by Fourier method, but the post-tensioning is done by Prestressed system, Lee-Meckels system, Prestressed system, Lee-Meckels system, Magnell Blatten system. Next one is Gifford Dahl system. So they will ask you in the examination which one of the following is the post-tensioning method or pre-tensioning method, like that. So this is very, very important, the state and the central government examination question. Okay, what are the methods which was used for pre-tensioning, post-tensioning? You have to keep the Hoyer method. So only one method which is available for pre-tensioning and other four are for post-tensioning. Okay. Now we are going to see assumptions in the analysis. This is also important. Okay. Before that, let me write one or 2 points about pre-tension and post-tension. Pre-tensioning concrete is poured after stressing of steel. Post-tensioning here in the pre-tensioning means first of all we will stretch the steel. Okay, that we will give the pre-tensioning force. Then what we will do, we will pour the concrete within the mold. After that we will cut a steel so that the whatever stress we gave to the steel will be transferred to the concrete. Okay, now next one is post-tensioning. In the post-tensioning, steel is stressed after pouring of concrete. After pouring or after hardening of concrete, we can say after pouring or after hardening of concrete. The reverse of pre-tensioning is a post-tensioning and vice versa. Okay, pre-tensioning means we are tensioning the steel, okay, before pouring the concrete. Post-tension means we are pouring the concrete uh, after, that means we are stressing the steel after hardening of concrete. First we are pouring the concrete, after that only we are stressing the steel. Okay, the reverse of pre-tensioning is the post-tensioning. Okay, next we are going to see is the assumptions in the analysis. Third one, assumption in analysis. What are the assumptions that we have to keep in our mind? The first one is plane section remains plane. Plane section remains plane after bending. Plane section remains plane after bending. This is the first thing. Second one is concrete and steel. Okay, concrete and steel of cable are assumed to be are assumed to be linearly elastic. Are assumed to be linearly elastic. Here the concrete and steel of cable is assumed to be linear material. What is the meaning of linear material? The stress strain curve obeys the Hooke's law. Steel stress strain curve also obeys the Hooke's law. Okay. Next one is no variations of stress. No variations of stress. No variation of stress of cable is considered along length of cable. Okay, therefore here there is no variation of stress in cable. There is no variations of stress of cable is considered along the length of the cable. Along the length, there is no variation in the stress, meaning the stress is uniform. Meaning everywhere, meaning everywhere force is same. Meaning everywhere the force is same. Next one is no variations in stress in wire or cable due to bending of member. Okay, no variations of stresses in wire or cable due to bending of member. Due to bending of member. So no variation of stresses in wire or cable due to bending of member. Okay. So due to bending of member also there is no variation of stress. So this also you have to keep in your mind. Okay. Now next fourth one is analysis of prestressed concrete member. Analysis of prestressed concrete member. So this is important. So let me explain this. So listen, there was a prestressed concrete member. So this is the concrete member. You know, this prestressed concrete member. So this is the neutral axis. And this is the prestressed element. So from here to here, this distance is E. This distance is E, and here the load is UDL. The external load which is active, UDL. you know, here the force is P. P is the force which is subjecting, we can say, on the pre-stressed concrete member, the force P is subjecting. On the pre-stressed concrete member, the force P is subjective. Now, the analysis is done by first one. There are two ways: stress analysis due to external load, plus the stress analysis due to pre-stressing force, okay. There are two analyses. One is due to external force, another one is due to pre-stressing force. That is the thing. Now, here the analysis due to pre-stressing force. First, analysis due to external load. In the external load, you have to take first of all only the beam without. I'm converting this into only beam. I am taking this is only beam with there is no pre-stressing force. Only external load is acting. Only external load is acting. So because of that, how it will bend? So this will be bent something like that. This also will be bent in something like that. Okay. Now the top fiber is subjected to compression, bottom fiber is subjected to tension. Because of that, if you take any section XX, if you take any section XX, then in the cross section, the top one is subjected to compression. So we can take the FC, compressive stress. The bottom is subjected to tensile stress, that is FT. Okay, this we getting from bending theory. What is a bending theory says? M by I is equal to F by Y. So here now F is equal to, we can write M into Y divided by I. I is the moment inertia of the section, M is the moment. So for this case, what is M? M equal to W L square divided by A. Okay, so that is the so now we got it. This simply supported with this. Now next analysis is plus the simply supported beam with only pre-stressing force. You have to consider only pre-stressing force. So pre-stressing force. So this is the neutral axis. And the pre-stressing force will be at like that. So this is the eccentricity V. Okay, eccentricity V. Now this is the force which is acting P in this direction, only pre-stressing force P. You have to resolve this force with respect to the center. There is a neutral axis. Then while converting this about the neutral axis, you know how it will go? So it will go 1P and P into E and P into E. And this is P and P into E. So that is the thing. P and P into E. Okay. Now if you look any cross section, if you see any cross section, if you see any cross section X, so in that cross section, first the cross section is subjected to direct stress. The cross section is subjected to direct stress. So this is B, this is D, and this also B. The same cross section D. It is subjected to first one is a direct stress. Due to this P. So this is P. P by A, direct stress. This also P by A. So because this is a compression, take it as a positive. And in this case also, top is compression, bottom is tension. Therefore negative. And because of this moment, how it will bend, the beam getting bends something like that. So it will bend is something like that. Because of this pre-stressing force, the beam bends something like that. Okay. Therefore now here the top is subjected to tension and bottom is subjected to compression. Top is subjected to tension, so this is the tension, and bottom is subjected to compression, so this is the compression. So this is FT, this is FC. Okay, FC. And this is minus and this is plus. How can we calculate this FC? So this is same as the bending formula. M by I is equal to F by Y. But here F is equal to what? M Y divided by I. Here M is equal to what? P into E. Moment due to pre-stressing force. But here moment due to external load. Now summation of these three. The summation of these three in the stress block. This stress block. This stress block. Because these all stresses are acting at a same point. That is the same section, right? Therefore, the net value is here. This is the positive, this is positive, this is negative. So depends upon the value, you will get a net stress on this section is maybe you will get something like that. This I'm saying maybe depends upon the value only. And here negative, positive, positive. So here maybe depends upon the value. It may be okay. You will get something like that. We don't know exactly, but something like the stress distribution diagram you will finally. What is the top? Compressive force plus P by A direct stress minus tensile stress. Similarly here, Ft that is minus plus P by A plus Fc. So this is the analysis of prestressed concrete structure. Okay. Now, next we are going to see the different stages of loading. Fourth one. The fifth one is different stages of loading. Different stages of loading. Different stages of loading in that transfer stage and final stage. First one is a transfer stage and final stage. Transfer stage and final stage. So in the transfer stage, transfer stage, it is just after transfer of pre-stressing force. After transfer of pre-stressing force. Transfer means what? Meaning this is the pre-tensioning member. Uh, Initially you are tensioning the member, the tensioning the steel. After that, you are after hardening of concrete, you are cutting this pre-stressing member, that is a cable, so that at the instant of cutting, this force is transferring. That is a transfer stage. The force is transferring to the concrete. Okay. So just after transfer of pre-stressing force is a transfer stage. Okay. The next one is no loss of pre-stress is considered. At the transfer stage, no loss is considered. No loss of pre-stress, no loss of pre-stress is considered. That is P is equal to PI. Now, next point is only dead load and pre-stressing force, only dead load and pre-stressing force is considered. In the transfer stage, we will consider only dead load and pre-stressing force. Okay. But in the final stage, after application of all possible loads. So the final stage of transferring is after application of all possible loads. Once you apply all possible loads, then what is the thing? There is a loss of pre-stress is possible. So here all losses of pre-stress is considered. All losses of pre-stress is considered. And here pre-stress with losses plus dead load plus live load plus all possible other loads are considered. Okay. At the final stage, in the transfer stage, we will consider only dead load and pre-stressing force. But final stage, we will consider pre-stress with the losses, dead load, live load, and all other possible loads we are considering. Okay. So you have to read this. The statement question they will ask you in the SSC or state government examination for about the different stages of loading. Okay. Next one is losses of pre-stress. Very, very important. This losses of pre-stress. Losses of pre-stress. The first one is due to elastic shortening of concrete. Due to elastic shortening. Due to elastic shortening of concrete. Second one is due to creep of concrete. Due to creep of concrete. Third one is due to shrinkage of concrete. Due to shrinkage of concrete. Fourth one, due to relaxation or creep of steel. Due to relaxation or creep of steel. Fifth one, due to anchorage slip. Due to anchorage slip. Sixth one, due to friction. Due to friction. Okay. So this is all about loss of pre-stress. Now these losses can be further classified into short-term, long-term losses. Okay. What are the short-term losses and what are the long-term losses? First one is short-term and long-term. Short-term and long-term losses. Short-term losses and long-term losses. So this is this. Short-term losses. First one is elastic shortening of concrete. Elastic shortening. Elastic shortening of concrete. Long term. And next one is anchorage slip. They will ask you by giving any one of them and ask you what is the short term losses which are the following below. Okay. Next one is loss due to friction. Next one is loss due to friction. Loss due to friction. Long time losses, creep of concrete. Creep of concrete. Shrinkage of concrete. Shrinkage of concrete. Next one is relaxation of steel. Relaxation of steel. This is all about long-term losses. Now, further, we can see this. What are the pre-tensioning losses, post-tensioning losses? Pre-tensioning losses and post-tensioning losses. So that also we have to see. Okay. Pre-tensioning losses, we can see. Okay. The pre-tensioning losses, we can see. What are the pre-tensioning and what are the post-tensioning losses? First one is pre-tensioning losses. Pre-tensioning. Next one is post-tension. Next one is post-tensioning losses. Okay. Now here the pre-tensioning losses is elastic shortening of concrete. Elastic shortening of concrete. Elastic shortening of concrete, then creep of concrete, and next one is shrinkage of concrete, Next one is relaxation of steel, relaxation of steel. The relaxation of steel also call it as creep of steel. Okay, creep of steel. This is all about pre-tensioning. Then post-tensioning, that is loss due to elastic shortening of concrete is not present. Loss due to elastic shortening of concrete is not present. In case of, that word is important, in case of simultaneously tensioning. But it is present. Okay, loss due to elastic shortening of concrete is present in the case of successive tensioning. And see, this is important. Pre-tensioning member, elastic shortening of concrete is there. But in the post-tensioning, elastic shortening of concrete is not there if it's simultaneously tensioning. But successively tensioning, then there is a loss. Then all other losses. See, the thing is, here there is no frictional loss. In the pre-tensioning, no loss of friction. But here, including loss due to friction. This is the question they will ask you. What is the question they will ask you? In a post-tensioning member, loss due to friction is mandatory. But in the pre-tension member, there is no loss due to friction in pre-tensioning. But loss due to friction in post-tension is there. Okay, so these are some of the important points that you have to keep in your mind. Okay, so next, this is all about friction. Now we are going to see one by one what are the losses. The first one is we are going to see loss due to elastic shortening of concrete. Loss due to elastic shortening of concrete. Loss due to elastic shortening of concrete. So loss due to elastic shortening of concrete that we are going to see. Here is loss is M into stress in the concrete. Okay. So M is the modular ratio. And FC stress in concrete at the level of tension steel. Okay, meaning this is the concrete member, the section. This is your neutral axis. In that neutral axis, somewhere here you are having a member, and this is the center line of the steel bar. The FC is calculated concrete up to this center point of steel. This is the FC. Okay, now FC My divided by I. Here this distance is I. Sorry, Y. From neutral axis to center of the reinforcement. So this modular ratio is equal to Young's modulus of steel divided by Young's modulus of concrete. So this is the first one. The second one is, this is the loss due to elastic shortening of concrete. Next one is loss due to creep of concrete, loss due to creep of concrete, loss due to creep of concrete, so which is finally written as loss, which is equal to theta into m into fc. Fc already we know, theta is a creep strain. Theta is the creep strain, which is equal to, which is the ultimate strain of the concrete. So that they will give you. Next one is loss due to shrinkage of concrete. Loss due to shrinkage of concrete. Loss due to shrinkage of concrete, you know, here the loss which is equal to, what is the shrinkage of concrete? We can write loss equal to shrinkage strain of concrete into Young's modulus of steel. Here the shrinkage in concrete is equal to 3 into 10 raised to minus 4 into Young's modulus of steel. Okay, this is for pre-tension member. Pre-tension member. Next one is loss is equal to strain in concrete into Young's modulus of steel, which is equal to 2 into 10 raised to minus 4 the whole divided by log t plus 2 log t plus 2 into Young's modulus of steel. This is for post-tensioning member. This is for post-tensioning member. Post-tensioning member. Okay, where T is equal to what? All others are, you know, T is equal to age of concrete. Age of concrete in bracket in days. This you have to keep in your mind. In days. At the time of transfer of pre-stressing force. At the time of transfer of pre-stressing force. This is loss due to creep shrinkage of concrete. Okay. Next loss that we are going to see, the important thing is loss due to anchorage slip. Loss due to anchorage slip. Loss due to anchorage slip that we are going to see here, the value is loss delta divided by L into Young's modulus of steel. Here, what is a delta? Delta is equal to slip, anchorage slip. Anchorage slip. L is a total length of member. Now delta by L means what? Is a strain. We can write as a strain. Now next one is loss due to friction. Loss due to friction. What is the loss due to friction? Here the loss due to friction, loss is equal to P naught into Kx plus mu alpha. So this is the loss due to friction. So now here loss due to friction, you know, here X is equal to, see, in the loss due to friction, you have to keep this in your mind. Okay, the first one is x. X equal to distance between point of application of point of application of point of application of pre-stressing force and point under consideration along longitudinal length of member, along longitudinal length of the member. See, this is the neutral axis. This is the member. Okay, here x is considered. This is the point of application of pre-stressing force, for example P. From this point to the point where we are considering the pre-stressing loss. Suppose this is the point, for example, from here to here is the x, loss due to friction. If you want to find out the loss due to at this point due to friction, then you have to measure x from point of application of pre-stressing force to point where we are considering, that is a x. Okay, now next point is x is over. Now mu is the coefficient of friction, coefficient of friction, that is 0.17 to 0.25. Coefficient of friction, that is 0.17 to 0.25, and k is equal to constant that depends upon constant. K is the constant that depends upon profile of cable. That depends upon profile of cable, that is 0.02 per meter. Then is alpha. Alpha is equal to cumulative angle in radian. Cumulative angle in radian. Cumulative angle in radian through which tangent on cable profile turns between point of application of pre-stressing force and point under consideration So alpha is the total cumulative angle. This is the point of application of pre-stressing force. This is the, for example, point of concentration. So this alpha is equal to angle between. So if you try a tangent here, point under consideration. Okay, point under consideration. For example, suppose if we consider somewhere here, this is the point under consideration. Draw a tangent at that point, and angle between these two is the alpha. This is all about loss due to friction. Okay. Now, till now we having seen losses due to pre-stressing force. Now we are going to see some of the important points under pre-stressing. So some of the codal provisions. So actually this is topic number 6-7, right? Topic number 7. Okay, so now everything's K, X, mu, alpha, everything's fine, right? P naught is what? Initial pre-stressing. Initial pre-stressing force. Initial pre-stressing force. So now the seventh one. Seventh one is codal provisions of IS 1343212. Some of the codal provisions. First one, minimum M30 and M40 concrete grades is used for post tensioning and pre-tensioning. Post tensioning and pre-tensioning. So this is very, very important. For post tensioning M30, for pre-tensioning M40. That's the first point. Next point is tensile strength of concrete. Tensile strength of concrete is 0.7 root of FCK. That is the next point. Next one is modulus of elasticity. Modulus of elasticity of concrete is 5000 root of FCK. That's the third point. Fourth point, minimum clear coverage. Minimum clear cover is 20 mm and a dia of wire for pre-tension member, pre-tension and post-tension member respectively. Post-tension member respectively. See here, the minimum clear cover is 20 mm and the diameter of wire for pre-tension and post-tension member respectively. Therefore, for minimum clear cover for pre-tension 20 mm, post-tension diameter of the wire. Okay. Now, next point, spacing. Spacing of cable. Okay, spacing for pre-tensioned member. Spacing greater than or is equal to maximum of 3 times the diameter and a nominal size of coarse aggregate plus 5 mm. So nominal size of coarse aggregate plus 5 mm. This is all about pre-tension member. Now post-tension member. Post-tensioned member spacing of post tension member greater than or is equal to maximum 140 mm. 2. Dia of duct. Third one, nominal size of post aggregate plus 5 mm. So these are the important points. Okay. Now, next point, dia of ducts. Okay, dia of ducts is 2 to 2.5 times 2 to 2.5 times the dia of wire. 2 to 2.5 times the dia of wire. Okay. Next one is longitudinal okay reinforcement. Longitudinal reinforcement is first one, minimum 0.2 percentage and 0.15 percentage of gross area for mild steel and HYST bar respectively, for mild steel and HYST bar respectively, including area of pre-stressing wire, including area of pre-stressing wire, including the area of pre-stressing wire, that is FE 250, FE 450, FE 500. Okay. Second point is for depth more than 500 mm, 0.1 percentage gross web area is provided. Gross web area is provided as side reinforcement. Which is equally distributed on both face with spacing not more than 200 mm. For depth more than 500 mm, 0.1 percentage of gross web area is provided as a side reinforcement. So that means this, as a side reinforcement, which is equally distributed on both sides. Okay, this side and this side. Okay, this side and this side, and the spacing should not be more than 200 mm. Should not be more than 200 mm. Okay, so this is very important. Okay, next one is we are going to see, that is some of the important points about that is, this is 7th point, right? Eighth one. Eighth one. Effect of a stress. Effect of a stress. Stress of cable due to bending member. Due to bending of member. Due to bending of member. Okay. First one is, so in a pre-stressing member, so this is the steel bar, which is subjected to force P, and here also subjected to force P. This is the eccentricity. Okay, in this case, this is the negative, and this is the negative bending moment. So bending moment due to pre-stressing. Bending moment due to pre-stressing. Okay. Now, because of this bending moment, what kind of deflection will be happen? The deflection is something like that. This is theta 1. Okay. This is the support. This also is support. This is the theta 1. Let us consider. Next one is due to dead load, due to external load. What is the bending diagram that we will get? The bending diagram is this one. The bending diagram is this one. And this value is WL square divided by 8. WL square divided by 8. And the deflection is because of this, it will deflect something like that. Okay, this is deflects something like that. So now this is the theta, this is theta 2, and this also theta 2. Theta, okay, this is bending moment due to external load. This is bending due to pre-stressing. This is the bending moment due to external load. Okay, now in that we are going to see first of all case 1. Some of the important points. Case 1. Case 1. If theta 2 is greater than theta 1, that means deflection, that is a slope due to external load, is greater than slope due to pre-stressing force, then the total elongation of cable happen. The total elongation is equal to 2e theta. 2e theta. Okay. So because of this elongation, this gain of stress will be happen. Gain of stress equal to, this is the change in length, the total elongation divided by original length of the member, you will get a strain. This is the actually strain. This is actually strain into Young's modulus of steel. into Young's modulus of steel. Now, case number 2, that is theta 1 is greater than theta 2, which is equal to total shortening of cable. Total shortening of cable is equal to 2e theta. So if the pre-stressing force slope, the slope due to pre-stressing force is more, then the loss of stress will be happen. Loss of stress. So they will ask you this loss of stress how much. So 2a divided by length. This is the strength into Young's modulus of steel. So this is all about that. Okay, this you have to keep in your mind. And some more thing that I am going to give, that is the next topic. What is this? Is 8th, 9th one. Deflections due to pre-stress. Due to pre-stress. Deflection due to pre-stress is some of the points. Suppose there was a this is the center point, that is a neutral axis. You know, this is the cable. This is the cable. We provide as a parabolic cable, and this is the E. Now, the delta, which is equal to 5 by 48 PEL square divided by the flexural rigidity. The next one is this is okay. Your cable is this, something like that, a triangle. Then here the delta is equal to 1 by 12 PEL square divided by flexural rigidity. The next one is this is the center point, neutral axis, and here this is the eccentricity E, and here this is the center point eccentricity. If you provide cable as a straight, then deflection is equal to PEL square divided by 8EA. Now, some more formula that we are going to write, that is, if your cable is something like that. Now, in this case, is something like that. Okay. So this is your cable, and this eccentricity is E2 and the center eccentricity is E1. This is E1. Now delta, which is equal to PL square divided by 24 EI into minus 2 E1 plus E2. The next one is This is the center point. It's a triangular shape of cable, but now it's a parabolic shape of cable. So this is E2 and this is E1. This is E1, center point. In this case, the deflection is equal to PL square divided by 48 EA minus 5 E1 plus E2. So these are the important points that you have to keep in mind in the examination.